This is SpaceTime Series 27, Episode 92, for broadcast on the 31st of July 2024. Coming up on SpaceTime, Planet Earth placed on La Niña watch, the first rumblings of the Sun's next solar cycle identified, and tiny chips containing human muscle cells sent into space for experimentation. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
With planet Earth having only just officially ended its latest El Niño weather pattern, the Bureau of Meteorology in Australia has officially moved the world into a La Niña watch, meaning an increased risk of more wet weather and flooding for eastern Australia later this year. The El Niño Southern Oscillation Pattern, ENSO, is the strongest driver influencing Australia, for that matter the planet's weather and climate patterns, on a year-to-year basis. El Niño, meaning little boy in Spanish, is associated with extended periods of warming sea surface temperatures in the central and eastern tropical Pacific, and cooler waters in the western tropical Pacific around Australia. Its counterpart, La Niña, or little girl, is associated with extended periods of warmer sea surface temperatures in the western tropical Pacific near Australia, and cooling temperatures in the central and eastern tropical Pacific near the Americas. The names come from Peruvian fishers who noticed reduced catches of anchovies during El Niño events. The southern oscillation is the accompanying atmospheric component linked to the change in sea temperature, with El Niño causing high surface pressures in the tropical western Pacific and La Niña lower pressure and a shift in atmospheric circulation. Now, typically, the equatorial trade winds blow from east to west across the Pacific Ocean. El Niño events are associated with a weakening or even reversal of these prevailing winds. In Australia, El Niños tend to result in periods of high temperatures, reduced rainfall, increased drought, and a high fire danger, while the Americas tend to experience increased rainfall, flooding, and greater storm activity. And the opposite, La Niña, tends to cause increased rainfall in winter, spring and summer along Australia's Pacific coast, stretching from the tropical northwest right down and across to the temperate southeast of the country, with more moderate temperatures and flooding in some areas. Predictions for La Niña and El Niño are usually based on past historical records, with 4-year cycles usually being the average, and with La Niña events often but not always occurring immediately following an El Niño. However, record global sea surface temperatures over the past year and an extended series of 3 back-to-back La Niña events prior to that have made current forecasts far less reliable based on past events. Now, the Bureau stresses that a watch declaration isn't an announcement that a La Niña has arrived, but simply an indication that there's a 50-50 chance of it developing over the next few months. However, the United States National Oceanic and Atmospheric Administration, NOAA, has been more definite, putting the chance of a La Niña event developing over the next 2 months at 69%. In fact, right now, meteorologists are monitoring a large mass of abnormally cool water just below the surface of the tropical western Pacific, which could upwell in the next few weeks, causing a drop in surface temperatures and the rapid development of a La Niña event. If La Niña does make an appearance, it would be the 4th such event in 5 years, a frequency only seen twice previously since records began back in 1900. The Bureau of Meteorology's senior climatologist Agita Emilska says the El Niño Southern Oscillation Pattern, or ENSO, is the strongest driver influencing weather and climate on a year-to-year basis.
Australia's highly variable climate is influenced by the broad patterns in the oceans around it and the atmosphere above it. Some of these patterns are not only more obvious than others, but also predictable. We call these our climate drivers. One of our strongest climate drivers is the El Niño Southern Oscillation, or ENSO. ENSO is a natural cycle in Pacific Ocean temperatures, winds, and cloud. This influences climate right around the globe. In Australia, ENSO is often behind our climate extremes, from devastating floods to searing droughts. ENSO naturally swings between 3 key phases: La Niña, neutral, and El Niño. A typical ENSO phase starts in the first half of the year and lasts until the following autumn. Sometimes we can get the same phase for 2 or more years in a row. On average, it takes about 4 years to swing from El Niño to La Niña and back again. So what are these ENSO phases, and how do they impact Australia's climate? Well, during the neutral phase, steady trade winds blow across the tropical Pacific from the east to west. These winds pile up warm water in the western Pacific. In contrast, water temperatures to the east are lower as the trade winds cause cool water to be drawn up from the deep. The temperature difference across the tropical Pacific Ocean causes air to rise to Australia's north and descend near South America. This creates a huge connected cycle called the Walker circulation. We consider neutral to be the normal phase because we're in this state more than half of the time. While a neutral phase may bring more normal weather to Australia, droughts and floods are certainly still possible. When we move into a La Niña, it's a bit like the neutral phase has gone into overdrive. The trade winds blow harder, expanding the warm pool on the Australian side of the tropical Pacific and cooling the oceans towards South America. This increases the east to west temperature difference and makes the Walker circulation even stronger and the trade winds blow even harder again. This is called a feedback loop, and once it starts, we're locked into a La Niña until at least the following autumn. With the higher ocean temperatures, we get greater evaporation, more cloud, and more rain in the Western Pacific. For Australia, this means a higher risk of widespread flooding, lower daytime temperatures, and more tropical cyclones. On the other end of the scale, we have El Niño, which is almost the direct opposite of La Niña. During El Niño, the trade winds actually weaken or reverse, allowing warmer waters to drift back towards the east. The change in the ocean temperature patterns mean the Walker circulation breaks down, resulting in even weaker trade winds and even more warming in the east. Once this feedback starts, El Niño has set in. With the warm water shifting east, the evaporation, cloud and rain follows, shifting away from Australia. That means a greater risk of drought for northern and eastern Australia, higher temperatures and more heat waves, clearer nights and a longer frost season, and fewer tropical cyclones. While there are scientific definitions for El Niño and La Niña, in reality, no two events and no two sets of impacts are exactly the same. We also know some impacts will emerge as an ENSO event is developing, and some will persist even if an El Niño or La Niña never fully forms. The Bureau updates the status of its ENSO tracker whenever an event may be on the horizon, so you can keep well ahead of the game. Understanding ENSO is a big part of understanding our climate.
That's the Bureau of Meteorology's senior climatologist, Agita Milska. And this is SpaceTime. Still to come, the first rumblings of the sun's next solar cycle, and human muscles placed on a chip and sent into space for experimentation. All that and more still to come on SpaceTime. The first rumblings of the sun's next 11-year solar cycle have been detected through sound waves identified deep inside the star, even though it's still only halfway through its current solar cycle. The existing solar cycle, known as 25, is now close to its peak or solar maximum. We'll know when that happens because the sun's magnetic poles will flip as its polarity reverses. The north pole will get a south polarity, while the south pole will get a north. And that's expected to happen sometime between now and the middle of next year. It affects activity on the sun's surface, with sunspots, solar flares and coronal mass ejections all becoming far more rampant during solar maximum. That leads to a surge in electromagnetic energy hurtling towards the Earth and making the aurora australis and aurora borealis, the southern and northern lights, occur far more often and at lower latitudes. The current solar cycle is identified as 25 simply because it's the 25th since 1755, when extensive recording of solar sunspots began. Solar cycle 25 started in 2019. The Royal Astronomical Society's National Astronomy meeting in Hull has been told that while it's not expected for another 6 years, the first signs of the next solar cycle, 26, have already been detected. Astronomers use the sun's internal sound waves to measure how it rotates, making visible a pattern of bands and solar torsional oscillations that rotate slightly faster or slower. These move towards the sun's equator and poles during the activity cycle. And faster rotation belts tend to show up before the next solar cycle officially begins. And astronomers have now discovered a faint indication that the next solar cycle is starting to show up in the data that they've been analysing from the rotation bands. The study's lead author, Rachel Howe from the University of Birmingham, says that if one goes back one solar cycle, that's 11 years, you can see something similar seems to be joining up with the shape seen in 2017. And that went on to feature in the present solar cycle 25. Howe believes it's likely we're seeing the first traces of solar cycle 26, which won't officially start until around 2030. The solar torsional oscillation signals were studied using helioseismic data from the Michelson Doppler imager aboard the Solar and Heliospheric Observatory spacecraft SOHO and the helioseismic and magnetic imager aboard the Solar Dynamics Observatory spacecraft. The data now covers the first 4 years of solar cycle 23, as well as solar cycle 24 and 25, allowing researchers to compare the rising phases of these cycles. Howe and colleagues have been following changes in the sun's rotation for around a quarter of a century now, going back to when scientists only had a portion of the data from cycle 23. But they could see a pattern of faster moving material drifting towards the solar equator along with the sunspots. Since then, they've watched the pattern repeat, but not exactly, as solar cycle 24 came and went, and again as cycle 25 grew. This is SpaceTime. Still to come, human muscle cells on a chip sent to space, and later in the science report, a new study shows that chimpanzee communication is actually remarkably similar to that of humans. All that and more still to come on SpaceTime. Scientists have sent a set of human muscle cells into space to see how their growth is impacted in microgravity. The muscle chips, bioengineered packages of cells mimicking the structure of human muscles, were sent to the International Space Station to grow for a week. When they came back, researchers compared them with similar muscle chips left on Earth. They found that the cells grown in space showed various signs of dysfunction, including gene activities resembling muscles with sarcopenia. That's a type of muscle atrophy primarily caused by the natural aging process, which usually only affects humans aged 60 and over. The findings, published in the journal Stem Cell Reports, shows that it appears this process may be rapidly accelerated in space. Muscle chips in space that were spiked with experimental sarcopenia drugs were able to better resemble the chips that never left the Earth. And before you ask, there are no sarcopenia drugs that have as yet been approved for use in humans by the FDA.
Mandelbaum!
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. HIV vaccines tested as part of the PrEP-VAC trials have failed to reduce HIV/AIDS infection rates. The findings, reported at the AIDS 2024 conference in Munich, showed that there had actually been more infections in the two vaccines trialled than in the placebo group. The trials were conducted in Eastern and Southern Africa between 2020 and earlier this year. PrEP-VAC tested two different combinations of HIV vaccines and compared each to a saline water placebo randomization. One regimen combined the DNA HIV PT123 vaccine with the protein vaccine AIDSVAX-BE, while the other combined the same DNA vaccine, a modified non-dividing virus vector MVA Commander, and the protein-based vaccine CN54GP140. The schedule involved 4 vaccine injection visits, 3 over about 6 months, and then the 4th a year after enrolment. They showed conclusively that neither of the two experimental vaccine regimens tested reduced HIV infections among the study population. Across South Africa, Tanzania and Uganda, the countries where PrEP-Vax conducted its trials, UNAIDS estimates that in 2022, a total of 10.7 million people were living with HIV, and some 244,000 adults and children were newly diagnosed with the virus. Meanwhile, a report in the New England Journal of Medicine suggests a twice-a-year injection could help women avoid HIV infection. Their trial, involving adolescent girls and young women in South Africa and Uganda, compared pre-exposure prophylaxis PrEP tablets with a twice-yearly injection of a drug called lenacapavir. The authors found that none of the women or girls who received the long-acting injections acquired HIV. A new study shows that even though they can't speak, chimpanzee communication is still remarkably similar to that of humans. A report in the journal Current Biology showed that different chimpanzee communities across the world use gestures to communicate with their kind, and the researchers collected the largest ever data set of these interactions to look at how they compare to human conversations. The authors say that when watching chimpanzee gesture conversations, the chimps take turns gesturing at a rapid pace, similar to how humans quickly take turns speaking and even interrupting each other. The authors also found that some chimpanzee communities communicate faster than others, which is also similar to cultural differences that exist in humans. Scientists have developed an artificial intelligence called Neural GCM that's capable of both accurate short-term weather forecasts and longer-term climate projections. Neural GCM combines machine learning and physics-based methods, and in test it's proved to be every bit as accurate as the top European physics-based weather prediction methods used for 1 to 15-day weather forecasts. And it also matched the best existing AI and physics-based methods for predicting the climate 40 years into the future. When it comes to predicting the movement of cyclones, the new AI outperformed existing climate simulations. A report in the journal Nature claims that Neural GCM could lead to big savings in computing power, potentially reducing the carbon costs of weather and climate forecasting. X, the social media platform formerly known as Twitter, has celebrated its first year of operations. And X has far more users now than what it did under its old Twitter badge. It successfully repositioned itself as a free speech community soapbox, moving away from the often left-wing politically manipulated rubber stamp it had mutated into under the old Twitter banner. Stunning proof of its reach and success was its use by US President Joe Biden as the sole vehicle to announce his historic decision not to seek a second term in the Oval Office. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
That was a coup for X. He didn't go on TV. He didn't talk about this on any other platform, not on Mark Zuckerberg's threads. It wasn't something that was announced by the White House, but it was a letter without any US government or POTUS letterheads, but it was a letter on X. So now Elon Musk, not only did he have the first anniversary of Twitter being known as X is stronger than ever. There was all these complaints that it might be going down, but Elon has also activated the most powerful AI training cluster in the world with 100,000 NVIDIA H100 GPUs. So that is in Memphis, Tennessee. They've estimated to have spent between $3 and $4 billion US dollars on the project. Now, we also have the US senators wanting Sam Altman, the CEO of OpenAI, the boss of ChatGPT, to go into Congress to explain the AI safety practices at OpenAI, because there's claims that they've been rushing the safety testing. The government wants, or these senators want, the next foundation model available to the US government so they can test it, review it, analyze it, and assess it. And they also want to know if OpenAI will adhere to its commitment to spend 20% of computing resources for AI safety promise. That's a promise that they made when they had their super alignment team, which has since been disbanded. And there's also the news that Meta, which is, of course, Facebook, their open source AI called Llama has been released as Llama 3.1. And they're saying that it's more powerful than ChatGPT 4 Omni, which is, of course, the flagship program from ChatGPT. Now, Meta is using over 16,000 of these NVIDIA H100 chips, the ones that power ChatGPT. But Elon Musk, as I was just saying, has 100,000, so 8 or 9 times as many. And Mark Zuckerberg did announce earlier that this was coming. It's got a context length of 128,000 characters. It can chat in 8 languages, can write better computer code, solve more complex math problems. And Mark Zuckerberg has made the prediction that he thinks the Meta AI will be the most widely used assistant, passing ChatGPT by the end of the year. You'll need to access it with Meta AI on Facebook, Instagram, or WhatsApp. You can also use it for free on the Hugging Chat service without signing up.
That's Alex Zaharov-Reutt from Tech Advice Start Life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.